Hello and welcome to another amazing episode of Agency Automators. Today we're so stoked to finally have Robin Lord with us. Robin, welcome. How's it going today?
Hey, it's great to be here. Yeah, it's good. It's lovely and warm here, actually.
Oh, fantastic. Jordan, are you sunny and hot up in Toronto?
It is sunny, hot, and beautiful, so I'm a happy camper.
Cool. So today we're with Robin Lord from Brain Labs, formerly Distilled. He's going to give us a ton of information about all of his new favorite things happening in Python, tons of extensions, tons of modules, packages, all kinds of techniques that we haven't seen before, and we're super stoked to jump in. Robin, for those of us who might not have heard of you, even though you're like a mega rock star, how is your PJ? Do you know what a PJ is?
No, I'm not sure.
Your private jet? How's your PJ?
Oh, right. Wow. Yeah. Private jet, private jet's good. It's about 3 inches long. It can just, fit in a suitcase behind me. So,
I've been watching this show called Black AF, which is on Netflix in the US. It's super funny. And this
oh yeah.
guy talks about taking his PJ, so he's like taking his PJ to Fiji. Okay, cool. So for those of us that don't know you, can you give us a brief bio and let us know, just give us your background.
Sure. Yeah. So I'm a consultant, as you say, Noah, at was Distilled SEO team. We're now part of Brain Labs. I've been working with them for about 3 years now, and we in the SEO team specialize in the broad range of SEO, from content to pretty technical stuff. And I was quite lucky when I joined to have a few people like Dominic Woodman, and there's another guy called Stefan Solomonidis who helped me learn early on some Python techniques. And since then I've continued to kind of double down and build on that. So my day-to-day involves anything from client strategy to doing relatively large data processing with some of those tools.
When you say relatively large, what size of data are we talking about?
Yeah, good question. I mean, with Python, we'd be talking, millions to tens of millions of rows, and then if we need to go larger, then we'd probably put it into SQL or something like that, because there's no point burning out the poor laptop trying to crunch through that amount of data.
Wow. Okay, cool. Which is super funny because I was telling Jordan before the call how we're working on pushing just simple like crawl data up into the cloud. And I came up with a pretty cool solution with AppScript, but
Oh, nice.
you very quickly hit the 5 million cell limit with crawl data due to like how many columns are in a screaming frog crawl and everything. So my solution needs to be refactored.
Ah.
Cool. So you must be super stoked to be part of the Brain Labs team. I've been watching the code that they've been putting out for years and years, whether it's like automating AppScript stuff or whatever. It seems like you must be part of a massive powerhouse now.
Yeah, it is really cool actually. As you say, the Brain Labs team have been uh, for a long time a source of free code for marketers all over, and I've really respected the fact that it's written. There's no point us benefiting from it alone. We may as well share it. I think that's one of the best things about our industry, and potentially something that, on the topic of code, we're slowly inheriting from places like Stack Overflow, and even public GitHub, where people are saying, well, I made it. You may as well try it out as well. And it's really cool to join that big organization with things like a dedicated tech team as a team that's used to being scrappy and agile and putting together scripts that do this job. The kind of mix between the two is something that I see is going to be really exciting over the next few years, because we can join those two approaches and put together some stuff that neither of us would have come up with.
Ooh. So the types of tools that you're building, are you building, we call them kind of like point solutions, where you're trying to solve a micro process or a micro problem, or are you trying to build tools that have crazy functionality and have like a front end interface. Like, do you have an internal website portal that you use to do all the different tasks associated with tech SEO?
We have a combination of things. So it tends to go on a gradient, to be honest, because there'll be certain jobs we'll be doing and we'll be thinking, yeah, this is a pain because it's either loads of data or I'm going to have to do this same thing thousands and thousands of times. But it's not something anyone else is ever going to really have to do soon. Recently we needed to switch from our InVision account, which is where we hosted a lot of our old creative pieces, to having that content elsewhere. And that would have involved someone spending roughly 3 days flicking through each of the products and downloading each of the individual pieces, which our poor marketing manager just doesn't deserve that kind of abuse. So putting together something to help with that was very specific. It's not the kind of thing we expect to be shared, but it's still going to deliver enough value to be worth spending a few hours on it. We do have tools, like you say, that have a GUI where you're selecting clients and you're saying, yeah, I want you to move this data from here to here. Quite commonly, it's things like, yeah, we want all of our Google Analytics, Google Search Console, et cetera, data in BigQuery. And then we have a series of Data Studio dashboards that automatically pull them out. And funnily enough, that's quite related to what we were talking about earlier about Don Woodman's project, doing similar work.
Yeah, he's doing some pretty interesting stuff right now. He has just created a cool website. Not created a cool website, but added a service to his personal site. Can you remind us what that is, what his URL is?
Dom's website URL? That's a good question. I think it is dominicwoodman.com. He has a burning passion to make sure it's got .com domain. Yeah, it is just domwoodman.com.
Okay, cool. I'll share that as a string when we put this on YouTube. Very, very cool. And so how do you think about automation when you're approaching a challenge? I think that you have a really fascinating brain. I've seen a bunch of your speeches. I've read a bunch of your content. I want to get inside your head a little bit. I want to learn how you make decisions. Can you share with us how you solve problems?
Yeah, sure. Great question. And likewise, I'd love to hear your thoughts on the same topic, actually. I think that particularly at the start, when I was digging into things like this, a lot of it came out of having like an innate frustration with not knowing the answer to things. Like looking at a set of data and knowing, yeah, the answer is in here somewhere, but I'm going to have to spend hours and hours trying to work out where that place is, and I just don't have that kind of time. And that's how I started looking into the coding solutions. And honestly, at times, that can push me to create something that is a massive time investment to solve a problem that after I'm done, I'm thinking, I didn't need to know the answer to that after all. And I think that's often a question that I'm trying to ask myself more and more, when we start on these projects, what is going to be the value add from this piece of work? And that can lead to us producing something that, like you say, has a GUI and is something that we regularly use and is going to get all of our data into one place. That can lead us to producing an individual script that we can share fairly easily with people, maybe in something like Jupyter or Google Colab. Or that could lead to producing something that's just 10 lines long and only I ever look at it. But I try to force myself to comment every line all the same to get into some semblance of good habit.
Nice. Okay, cool. So tell us, what are we going to be talking about? What do you want to share with us? Is this the appropriate time for you to start sharing your screen?
Yeah, sure.
I want to make sure we don't stay on too long. Your time's super valuable. I need to give you.
I appreciate that. Likewise.
I need to give you sharing stuff. Okay, you should be able to share your screen now.
Cool. While I'm getting that up and running, I'd be really interested in your answer to that same question. You know, how do you find yourself approaching those problems? What do you think is the best way you found to approach it?
It's a fantastic question. So I solve problems. Typically, they come from business needs first, right? So like when I was running Bike Shop SEO before we merged with 2 Octobers, we were small and had major budget constraints. And so the budget constraints drove a need to automate as many processes as possible. And I had major time constraints. And the first challenge was solving reporting. And Jordan and I met in 2017 at MozCon Local. We sat next to each other one morning at a conference, and then we sat next to each other again the next day. And then that's how our friendship blossomed. But I needed to solve automated reporting as a challenge. And I would say that the method typically is just banging my head against the keyboard until I solve it. But in terms of the thought process,
into Google. Yeah.
In terms of the thought process, I think David Crevett had a lot to offer, which is to say that when solving processes, you stay on the surface as much as possible and you consider all the options of how you might solve it. You investigate them a little bit before going down any major rabbit holes. And then when you come up with an approach that makes sense, then you sort of, and that's kind of like in conjunction with like an overriding way of thinking about a process. You know, typically we're automating a process and we try and break it down to as many little steps as possible. And then we think about which of those steps, if any, can we automate or where it makes sense to automate. And then we start at the micro level and we work our way out to the macro.
Nice.
Simple.
I watched that episode, by the way, and that was fantastic. I thought you had some great thoughts. And yeah, that kind of lines up with what you were saying the other day about the fact that once you start to, if you're lucky enough to have the time to pick up some of these technologies, like whether you're working in Python or JavaScript or any of these things, you start to, I think, slightly differently in terms of these problems. You start to think about things in terms of repeatable chunks rather than I have this massive piece of work. And I feel like that can be really helpful. And that's something that I feel like it's a really nice side benefit of learning code, but it also doesn't need to be something that you only learn through learning code. And that's something that I'm kind of keen for us as a group of people who are already invested in it to find ways of spreading that to help people understand. And I think a lot of the no-code solutions actually at the moment are starting to drive people towards these things where you are taking exactly the same approach. You're breaking something up into individual tasks and having something semi-automated. But now the barrier isn't you have to know JavaScript to know this is possible. You know that there are individual services that can take you along the way. And even if you use if this, then that to join them together, you're getting a similar end result without some of the flexibility.
Totally. I feel like the coolest automation that I was a part of, potentially the coolest, was automating our feed processing, our pay-per-click feed processing. So we'd pull it in from a website, do all kinds of different transformations of the data to make it more clickbaity, and then output it up to Merchant Center. The way that we do it and the granularity with which we do it is on par with or even more flexible than tools like, potentially as flexible as Feedonomics and Data Feed Watch, but managed inside a sheet.
Nice. So it's all just interacts with like a Google Sheet or something.
Yeah. And AppScript takes you all the way that you need to go, which is pretty amazing.
Awesome. Yeah, I'm actually coming to believe more and more that Google Sheets is one of the best GUIs you can put together for a piece of code. Like it integrates so nicely with so many different tools. Everyone knows how to use it at this point, and nobody needs an account. Like so many of these other tools across the board, you know, from project management like Monday.com to data manipulation, people have to learn how to use that specific tool. And even if the UX is fantastic on it, there's still that period where they're having to learn, the hamburger menu in this tool takes me somewhere completely different. I have to just learn the quirks of it.
Yeah. Sure.
Whereas Google Sheets is just so widely used at this point.
Yep. Cool. Jupyter.
Yeah. Yes. So let's jump into that. So for anyone who's not familiar with Jupyter, it's a way that you can run code quite interactively. So you may be familiar with the black and white lines and lines of text that's all pretty intimidating and hard to work with. This is a nice way to actually do what you were talking about earlier, Noah, chunk it up into individual processes that you can run step by step. I've spoken a bit about Jupyter in various points, but when you boil it down, it becomes as simple as Excel in a number of ways. It's just about what I was saying a minute ago, getting over the initial quirks of working with the system. I'm sure a lot of people listening to this podcast actually will be kind of familiar with Jupyter by now, so I won't spend ages talking about it, but I'm going to talk a little bit about some of the plugins that I've found for Jupyter that make life really easy. So at the moment here, we've got our script, and what we're going to be doing in this script is working with Google Trends, and I'll talk you through the use case now in a sec. But the first thing that we do when we're working with Python is import a series of libraries. So if we want to spend time waiting in between individual actions, say we want to do something and then wait for 5 seconds, we can use the library time to just deal with all that logic for us. If we want to print out the time that we've done something, we can use date time. And we're also going to be using Selenium, which is a web browser automation software. And we're going to use that to first open up a web page, do some things on that web page, and then download the result. I may actually need to switch my method of screen sharing to show that to everyone, but that's fine. We've also got these libraries here. So OS is a Python library that just lets us interact with our file system. And Glob works, the way I use it anyway, works quite closely with OS, and it's a really convenient way to just list files using wildcard searches. And the reason I have these two libraries in here is I think one mistake, certainly that I made early on with code, was I was able to generate a large amount of data, but then I wasn't filing any of that data in a nice way. And honestly, filing is one of the things that code is best at. So if we're using it to generate lots of stuff that we then need to manually file, we're losing 90% of the value that we can get out of code. So whenever I'm trying to do something that is repeatable or producing multiple data sets, I try to make sure that I include OS and Glob whenever I need to make sure that everything's sorted and filed for me in a nice way. And then Pandas is our last library here. And Pandas is one that basically does all of our Excel type tasks. So opening up CSVs, adding columns, removing columns, working with the data, that kind of thing. One of the things that often happens in Jupyter, because you can run each of these blocks individually, so I'm going to create a new block here, say A equals 1. We can run that. Now Jupyter, now our Python knows that whenever we say A, we mean the number 1. We're able to do these in any order. So I've run this. I don't have to have run anything above it in order to do that. It can be quite confusing to know what's happening when. And I've added in this little printout here is actually one of the plugins that I've come across in Jupyter recently, and it's really useful. It basically just shows you how long something took and when it's finished. So you can very quickly see the difference between two different cells and know, okay, well, yeah, the reason this one isn't working is because I've run them in the wrong order, for example. And you can also see if something is, for some reason, taking loads of time. Now, it's not uncommon for us to take a couple of seconds to import libraries because it's having to go and read a bunch of data. But if we're doing something else and we haven't realized we've made a bit of a mistake. We know it's going to take a little while, so we leave it to run overnight. This gives us an idea of where the slowdown is actually coming from. So that's one thing that I find really useful. Another plugin that I discovered recently is this variable inspector, which I absolutely love.
Wow.
So this isn't native with Jupyter, but it makes life so much easier because you can see everything you've defined in the document. As long as it knows what that thing is, it'll appear here. It'll give you what type it is, how large it is, what the actual value is. And then if you want to remove specific variables, you can just delete them.
So if you remove each chunk's some module, right?
Yeah, kind of, yeah.
I mean, what's the proper name?
As in each of these?
Yeah, like each one of those blocks.
I'd refer to that as a cell. That's
okay.
Normally the terminology.
So when you define a variable in a cell, and then you run it, and then you remove it, it's still in memory.
No, so now I've said b equals 1 here. Yep. If I ask what is b, just by writing b, it'll tell me, yeah, it's 1. Previously, I defined a. In fact, if I just delete b here as a variable and ask it again, it won't know what that is. Because
you had done
a.
I noticed when you did a equals 1, and then you deleted it and did b equals 1, it kept a over in the variable inspector, and I was like, oh, that's cool.
Right. Yes. So I understand what you're talking about there. So yeah, each of these cells, once it's completed its output, it doesn't rely on you having the same information in that cell for it to remain. So yeah, that can be useful in terms of keeping things clean. So for example, if you've got things spread around all over the place and you want to just cut and paste them all into one block so it's all happening at the same time, that's a great way to go.
Yeah.
The problems you can run into are, say we did this, we defined a equals 1, and everything was running fine, and we're pleased with our output. But when we're cleaning it up, we delete a equals 1. So now it's no longer in there, we've put in b equals 1 instead. Because a is still saved in memory, when we're working on the script, it's still going to work fine.
Got it.
But if we close it down, or if we send it to someone, as you know, is often the ideal when we want to make these things more transferable, if they then try to run it, because they don't have a cell that actually defines a, things will break later on down the road. So usually it requires a bit of thought. If we're basically, anytime I'm deleting anything, I like to have a look through it and make sure that I'm not relying on any of those things I've defined there.
Got it. And are the cells running synchronously if you run the whole script, or are they running async, i.e. they run out of order?
So yeah, so we can run them in any order, but they'll only run one at a time based on when we tell them to run.
Got it. So it's synchronous.
So yeah, exactly. So if we said, I want to, and we can actually use a command here. So if we create a new one, so what we'll do is we'll say print B, and then we'll do A2, print A. If we use the command cell run all above, that will just start at the top of the notebook, work its way down one by one.
Got it.
So it first did this, then did that, and we can see that, although it was too quick for it to show up in the timestamps, but as and when we had something that took a bit longer, we'd be able to see that show up there. Got
it. Sorry to ask dumb questions.
No, no questions are dumb questions. That's great. So we're starting by importing those libraries. So those are going to do a bunch of things for us. And what we're actually going to do here is work with Google Trends. So people may be sick of me talking about Google Trends recently, but I think it's a fantastic source of data. So we can use it, for example, to gauge the power of different brands in a specific territory. And that's what we're going to do here. So maybe we want to see how Nike and Adidas are doing in the US. Mikey's absolutely smashing it here. Maybe we say,
Oh, goodness.
we're going to have to find one that's roughly similar.
I would go New Balance and Saucony.
Nice, okay.
Two hipster brands that Pythonistas love to wear.
Awesome. So we've got a bit of a breakdown here in the map. And this is all data that we can export from Google Trends. It will give us a percentage breakdown of searches in each of these states. So if we want to get some idea of state level interest, we can use this data. Now, the problem is, this is a free tool from Google, which, as you will have noticed when we were working with it there, every time we made a new request, it was getting us that data in, what we say, like a second and a half.
Yeah.
Knowing how long it takes to process millions of rows of data, and knowing that Google, in order to get us this data, is having to process billions of searches, that response is almost suspiciously quick, right, for a free tool. And what they're doing is they are sampling, as is relatively expected. The way they're doing that is they sample the data and then cache it for around 30 to 40 minutes. So the results that we get out of this map can change if we ask it the same question 30 to 40 minutes apart, which is reasonable. But if we want to give someone the advice of making like branding decisions based on these numbers, we're going to want something a bit more reliable than, when you check the same map, you're going to be getting different results. And so what we're going to be doing with Selenium, which is going to be really gentle with the system, is we're going to ask it to come back and make this same request once every 40 minutes, just for a little while, so that we can get an idea of what the spread is between these percentages. And then from there, we can kind of work out what we think is an accurate answer.
Huh. That's kind of interesting. So did you see David's episode where we did Google Trends stuff with AppScript?
No, I'm not sure I did actually.
Oh, so that one. Whoa, as I
remember some of the AppScript stuff.
So we did something cool where we built a cloud function that connected to the unofficial Web Trends API.
Nice, yeah.
And you were able to plug in parameters like start date, end date.
Nice.
And I was wondering, when you were talking about different answers and caching, I was wondering how that impacts the data that's coming through the unofficial API too.
Based on the way I know those APIs work, because they're essentially breaking down the requests we make with this page into individual sub-requests, I expect the data that they get back to be the same.
Okay.
And so I'd still expect, if we're making those requests 40 minutes apart, to get that same spread, which, as I say, that's a problem when we're asking once. But actually, it's good for us if we're asking multiple times, because it means we can get an idea of what that spread is.
Got it. Huh.
Cool. So we've imported our libraries, and so we want to move on to the next phase. And this is a nice opportunity to introduce the other notebook plugin that I'm absolutely loving at the moment, which is just this table of contents. So again, this doesn't come native with the notebook, but as you can imagine, when you've got cells of code running individual steps, particularly when we're hacking around trying to make something work for the first time, or we're trying to improve something, it's really useful to be able to say, I know this is the step of the process that I want to work with, so I'm going there. And since I've added this, it's made my development cycle so much quicker and easier to understand for me, because this table of contents is just generated by these text cells, which you create here. Mm-hmm. So one thing it forces me to do is label everything and make it very clear what's happening where. And the other thing it means is I can just click between the cells. So whenever I'm moving on to the next thing, I can jump straight there rather than having to scroll up and down and try and work out what's going on. So in this second step, we're setting up Selenium, which, like I say, is a program that lets us remote operate a specific browser. And normally, Selenium, when you're using it with Python, you need to have a bunch of things set up. So you need to have installed things like your drivers, which basically allow Python to interact with the browser, and you need to have put them in the path of your system. Basically, all of this gets very complicated. And to be honest, I can't be bothered to set it up every time I'm working on a new machine. So instead of doing all of that, I just download the driver, and then you can pass that as an argument when you are setting up your Selenium instance. So that's all we're doing here is saying, here is a string. We haven't told Python that this is where a specific file is or anything. We've just said, this is a text string that we're going to use later on down the road. And when we start working with Selenium, we're going to use that text string to say, this is where all of those programs are that are going to help us run the browser. Then this bit here actually comes back to what I was talking about earlier, the filing side of things. So actually, normally when you're setting up a new driver with Selenium, you don't need any of this rubbish. Like, it can be 2 lines long, essentially, to say, okay, I want to start using Firefox in this instance. All of this stuff is overriding Firefox's default download location, because Firefox really likes to dump everything in downloads. We can't be bothered to have everything dumped in downloads. It's probably going to end up being file 1, file 2, file 3. It's no good to anyone. What we want is everything filed quite nicely. So all this is doing is saying, ignore that default. No, really ignore that default. No, definitely ignore that default. And then here we're saying, and save it here instead. We've also got a line here saying, don't ask me whether I want to save it, because if we want to automate something, we don't want to be having to click yes every time. So, and anyone who's not used to Python, but is used to other programs, this is just us defining a function. So when we call this later on, it's saying, do this specific block of code. So we've got that. Then we've got this, which is just getting a specific URL, which we're going to call later on. So driver is the thing we'll define, which just means this web browser we're working with. And then we'll use get to go to a specific URL, which is fairly common terminology. We've got get geodata, which is another function I'm defining. And all that's doing is go to this URL, wait for 5 seconds. So you remember we spoke about the time library before, which lets us just wait. Then find a specific element. In this case, that element is the download button. Click that element, and then save the time that we've done this as. And when we're done, we're just going to return the time that we've completed this action. We've got another instruction here, which is getting us the time series data. So instead of the map data, the data over time, but we're not going to dig too much in that. And we've got a function here, which is just checking if we've already saved a specific file. Because if we try to save something in a folder that doesn't exist, then things can fall over. So we make sure that anytime we try to save a file in a specific place, we first check that we're actually able to work there. I saw you unmuted there for a sec, John. Is there something you want to chat about?
Okay. So cool. My wife's in the shower and it's really loud, so but that's why I muted it. But I got to tell you, the table of contents makes the presentation of this
it's so much easier, right?
Easier to follow, and all the white space allows me to focus on what's important. It's wicked cool. Nice. I know that's trite.
Yeah, no, I'm a big fan.
You've had something. I didn't see where you define the download as a file in your.
So we've got So
A
this
couple steps up.
is,
I think in your setup Firefox cell.
yeah. So what we have when we eventually set up Firefox, because what has to happen when we're working with Selenium and Firefox is actually when you open up the browser, that's when you tell it where to save things.
Oh.
So when we're clicking a download button, we don't have the option at that point of saying, oh, and save it here. We have to say every time you open up Firefox, make sure you save everything in this location.
And where did you define that path? Is that in the right?
I'm going to do that. I'm going to do that later because
okay, cool. Got it. Sorry,
when
Rob.
no worries. When we go through this process, we're going to want to save different things in different locations. So actually, that's going to change as we progress.
Okay. I'm muting again.
Cool. No worries. So we've defined all of those functions. Then we get on to set variables. So this is when we're starting to lay out the specifics of what we want to do here. The first variable we're going to define is how many times we want to repeat this request. So we know this data is going to be changing over time. We know that repeating this request is going to increase our accuracy, but we also know that the correct answer for how accurate we should be is somewhere between 1 and 100 billion requests. And we probably don't want to be at the 100 billion level. So at this point, we're just going to say 20. Then this is where I'm defining, and this is a splurge of text that I don't expect everyone to absorb, but this is where I'm defining everything I want to do in a dictionary. So anyone who's familiar with JSON, that's just the format we're working in here. And we are chunking up every set of requests into a specific block here. So we're saying that within the US territory, we want to, and this is where we're setting our save file. We want to save everything in this location here. We want our start date to be this and our end date to be this. But then we also want to make another request where the start date is this and the end date is this. So later on, when we're going through, we're going to go to every location, to every set of dates, to every set of brands, and just go through each of them one by one, creating loops within loops, essentially. And then these are the actual set of competitors we want to look at. So we've got US sports brands, Nike, Adidas, Puma, etc., US footwear, and then smaller US sports brands, because actually when I was initially looking at this data, I found that it was fairly heavily bent towards certain competitors. So I've got a smaller bunch so we can see the variations a little bit better. And I've done that for a few different territories. So we'll run this to define it. And we can use this information now to work out how we're going to be as efficient as possible. So for example, we know that between every individual request, we need to wait 40 minutes. But if we want to find out a few different sets of information, what makes sense for us to do is within that 40 minutes, ask about other things and let those things refresh while this one is being asked. Does that make sense?
Totally.
Cool. So the first thing we need to do is work out how many different kinds of requests we're going to make. And we're going to do that just with a basic for loop going through this dictionary. So we start at 0 different requests. And then we say within our dictionary, go through every key value pair. So define the date value as dates. And for every different block of dates, we know that that's a different request. And define the request value, so the different brands we want to ask about, and for every block of those, that's a different request. So we end up with a request per territory, per date, per set of competitors. And in this case, that comes out to about 10 requests. So we want to split that up evenly between those 40 minutes. And that means that our wait time is 240 seconds. So we've defined all of that information. Then we just run our code loop. So again, this it looks longer than it is because it's so heavily commented actually, But all we're doing here is saying, okay, start by printing out the current date, because we want to know when we started this all. Then say our next request is going to be now. We're not going to wait at all. For each of our attempts, for each of the repeats that we want to do, we're going to go through each of the competitors, each of the dates, each of the territories. So again, we print out when this started because it's useful when we come back to it to know what's happening. And we're looping back through this dictionary. So we get the geography from the key there, we get the dates from the dates value, and we get the specific brands from the requests value. We use all of that information. And we use the file name when we're creating our driver instance, when we're loading up Firefox. So with all this information, we construct our URL, which, as you say, Noah, you can actually do with some of the unofficial APIs in exactly the same way.
Yep.
Sorry, go ahead.
No, I was just saying yes.
Cool. Okay, cool. We have our, we create our specific directory from the main save file that we defined earlier and the specifics of what we're working with. So we want every start date and end date block to be its own folder so that everything's nicely filed in different places. And that's where we define our driver. So we're opening up a new version of Firefox every time we start this loop. That's not a terribly efficient way to run because that's doing extra things than we ideally need to, but we need to do that if we want everything to be saved in the right place. And the fact that we're not trying to make, millions of requests at a time. We do want to be gentle with this, and we've got to wait a certain amount of time in between requests anyway to make sure it works. So it doesn't really matter that we're having to close Firefox and then open it back up again.
So can you talk us through the thought process of why you're saving everything in different folders? Like I typically am like grabbing data and putting it into one place. And I want to do things smart. So share with us your philosophy.
The reason particularly when we're doing things like this, so we've got a few different dimensions of the data. So we've got the geography, we've got the specific brands we're looking at, we've got the time frame that we're looking at, and we've got the variance within each request. Because something that is of the same geography, the same brand, the same time range, if we make that request multiple times, that data is going to change. At this point, we're not trying to compare two different territories at the same time. So actually, it's not useful for us to have that data in the same place yet, because actually it's just something we're going to have to separate later on. So the reason I want to chunk these into different files is because I want any time I'm going to a specific place to be honing right in on the specific facet of the data that we're working with, which is in this case, the variance between those dates. And then once I've accounted for that, once we know what our answer is in terms of that variance, then we can start combining things in terms of specific dates or specific territories, the rest of it.
And do you find that the delta across the same time frame is varies quite a lot?
Yeah, so I think actually the rest of this Selenium bit, I think we already kind of know what we're doing here. I would quite like to jump across to the next stage of this. So
good.
I've run this over the last month, the last week or so, just slowly gathering this data. And here's a script that I'm using to process that data. And we could have put this all in the same notebook. The reason I like to have this in a different notebook is, as you say, Noah, all of these cells run synchronously. So if we're doing something that takes a very long time, for instance, downloading files over time, we're not able to check those files in the same notebook until that long-running process is finished. So I like to have a separate notebook where I run things like this, and that helps us check. So again, we're going to be importing some libraries. We've got Glob and OS. Like I say, that helps us work with files and list files. We've got Pandas that lets us do Excel stuff. We've got a regex match function in here, and Plotly. Plotly is the thing that I really want to talk about here, because I love it as a graph generation tool. It's one of the best things I've come across in terms of this. So we'll run this. Then this is a function which is just going to help us clean up the data once we've got it. So when we're working with downloads from Google Trends, there'll be certain rows where it's like, oh, this is less than 1%. So it's literally writing less than 1%. That's not useful for us if we're trying to process things in terms of numbers. That's going to immediately trip up something like Pandas when it tries to do bulk interaction. So all we're doing here is basically stripping out anything that it could consider to be text. And then this is where we start to get into the body of it. So again, we've got our working folder here. We're defining the place that we want to look in. This is where we're using Glob. And all we're doing here is saying, okay, Glob, look in the working folder for anything that contains geomap.csv. And because we've got these stars, it doesn't matter if it's geomap1, geomap2, geomap3, we're able to list them all at the same time, which means that we end up with roughly 43 files. Then we can use, if we want, Pandas to open up one of those files and view it. And you can see there, we're just opening up the second file in the list. We're skipping the first row because Google Trends tends to put some junk in there at the top. And we're able to see a brief sample of what's going on here. So we've got each of the states, the predicted percentage for Kappa, Puma, ASICS, all of these places in 2018.
Be fascinating to overlay political party data with this.
It would, yeah. So the one thing I do find about these tables is they're not very interactive. Like, you've got this kind of nice hover animation, which is helping you see what row you're focusing on, but it's not something that's designed for you to be able to continue working with the data and seeing trends. There is this nice library here, tables, which is just a way to make tables a little bit more interactive. Or not. Yeah, we can maybe come back to that later on. But it is a way to make things more easily searchable as and when it decides to work. So now we've got our list of files. All we want to do next is combine them into one place to do exactly what you were talking about, Noah, work with all this data at the same time. And again, we end up resorting to just another one of these Python for loops, which you can see here, which is for every file in that list we created with Glob, add them together. So we've got load the file with Pandas, which we've just shortened to PD here. Clean the file to make sure that we get rid of all the text that might randomly appear, and then append that to a list. So we haven't yet combined them, but we've basically created a list of data frames. We've created a list of tables that we can then just add together later on. And we've got this in here, which is if for some reason there's something wrong with the file, for example, we've for some reason downloaded an empty file, Google Trends hasn't loaded properly, then print them out here. We can see there's some of the errors there, which, as and when we care about that, we can come back to it. So we've got our list of different data sets, our different tables. The next thing we can do is use Pandas to just mash them all together into one long table. And that's actually as simple as saying td.concat. So concatenate all of these tables top down. Because you've got the same columns, it recognizes exactly what you want to do. So we end up with this table, which is now 1,836 rows long. The next thing we want to do is use a function that I absolutely love in Pandas, which is called melt. So this is like the opposite of pivoting. If we normally had data that was, split up over a number of rows and we wanted to move that to being split up over columns, pivoting a table is actually very common. You know, like it's the kind of thing we would expect to be in any Excel type program, or it kind of really hasn't brought table stakes. It's much less common to have something that's willing to take all of those columns and turn them back into rows, which is often really necessary if you want to process that straight into a graph. Normally, graphs actually can't work out what you're saying if you have split things over a number of different columns, particularly if you're saying, oh, and there's also variance between these different things. It's much harder to get programs like that to understand. So all we're doing here with melt is saying, take everything that isn't region and stack it on top of each other. So now, instead of having different rows for kappa and theta, they're different columns rather, they're now rows, and the value there is exactly the same.
Oh, got it. Okay.
So now our table is much less wide, but much longer.
So
now
I heard that correctly. So what this enables us to do is basically do time series efficiently.
Yes.
Okay.
Yeah, essentially, or anything that involves taking data that is split out over a number of dimensions, but that we want to compare as one long series.
Got it.
And you'll see what we're able to do with it when we get to the Plotly section.
Cool.
So now we've got this melted data, which is what Plotly needs to automatically recognize what we're going to do. All I'm going to do here is define some variables. So first, this list is the colors we want to use.
You skip the calculating averages?
Yeah, that bit doesn't actually impact the data that we're going to see at the end here, and I don't think it's as interesting, to be honest. We can quite easily calculate averages across a data set by using a group by and mean function. But what I really want to talk about is Plotly, because it's pretty great.
Okay.
So first I'm going to define just some colors here in hex code. We don't need to do this, but what I wanted from these graphs is for them to match the Google Trends colors, so that when I'm talking about this data coming from Google Trends, for example, if I'm explaining it to a client, there's a nice, clear visual continuity between the two things. We've again got a save folder that we're going to put under here, and this is just defining the order that we want our competitors to appear in. So when we're creating the Plotly graph, we want it to start by putting in Nike and then Adidas and then Puma, etc. This is us running Plotly, and to be honest, we could remove this whole section. That wouldn't matter. That is just because I'm being fairly precious about what color the competitors show up in, because again, I want that continuity between Google Trends and this. This is Plotly doing its work, and all we're saying is take our melted data, so take the long table we've produced, use the region column for the X value, use everything that came up in the value column for the Y value, and then create us a box chart that shows us the variance between these things. So if we run this, we end up with a graph like this. So this is showing us exactly that same data that Google Trends was, except it gives us an idea of how much the different competitors are overlapping with each other. And that's the important metric that we needed, because we needed to get an idea of how accurate this data is, how likely we are to be right if we say, yeah, Under Armour is actually smashing it in this state. The stuff that I really like about Plotly is this is really interactive. So we've got a bunch of controls here. If we hover over any of the specific data points, it will give us more information on them. So like I say, we're talking about variance in this data. So we're going to have the median value, and then we're going to have the highest and lowest values. And then these quartiles are just the top quarter and bottom quarter. So this gives us a nice clear breakdown of that. If we wanted to see all of the data for that specific state anytime we hover, we can just change that setting. And it gets a little bit busy at times, but we can see that quite easily. And if we wanted to zoom in on a specific part, that's really easy to do as well. It's really nice to work with. And it's really easy to save HTML file of it as well. And then come back to that later on. In fact, there's one that I might try and pull up quickly, because the nice thing I like about this is we don't only have to look at one time, for example. We can look at the variance between two different time periods and see if we're doing reliably better in period 2 than we were in period 1. Because if we want to say to a brand, yeah, you're doing better in Montana than you were before, but we're getting variance between those two different data sets, then that becomes very difficult to reliably say. Whereas if we can say, yeah, we've looked at the variance between these two things, and even though there's high and low values, it's not as
so there's two things that I'm not necessarily two things, but one thing that's catching my ear, and I'm synthesizing this with your MozCon talk, but it's really interesting to me how granular you get with geography when thinking about how you're doing in search. And I want to synthesize that a little bit with something I saw in Bright Local the other day with Dan Leibson, which is, he said something like, national is dead. Like, we're only concerned with local search volume in order to grow revenue for our enterprise clients. Is that why? Is that how you got to this place in terms of how you got data?
So this actually, this is kind of related to what I've been thinking about a bit in terms of my clients. So I started working with a client in Asia Pacific a little while ago. And one of our big problems when we started the retainer is there was a whole bunch of ways in which we couldn't really help them. We couldn't do SEO in territories where people speak different languages and none of our tools work. Or at least we couldn't be as effective as we were used to being, and we couldn't drive the value that we were used to driving. So we needed to look for a way that we could work with 10 teams split across 20 different countries in 30 different languages, however many, that are all doing SEO, but they're also doing a host of other marketing efforts that could be positively or negatively impacting SEO as well through things like brand interest. So we started to look much more at country and territory level brand. And that's where we started to pull in this brand awareness data. And it becomes pretty difficult to make any reliable decisions when we're saying, oh, just be better in Australia or just be better known in Japan. You know, these aren't things that are actionable insights. So that's why we started to break it down at more territory level, and that's one of the reasons we started to use things like Google Trends to get that finer grained level of detail.
Got it. I lost your video. Are you?
Yeah. This is why I dialed in on mobile, just in case something like this happened. I could continue to rant while it did. But I think I'm on my way back in now.
Cool.
Awesome. Okay, great.
Did you make sure that your video is muted?
Yeah, so I haven't actually joined audio on my second instance of me. So, yeah. So Plotly, I'm a massive fan, and I'm going to attempt to wrestle the screen sharing from myself. Here we are. Yeah, Plotly makes this kind of stuff really nice and easy to visualize, and we can do things like toggling on and off specific competitors. This, particularly when we're dealing with data that has this many dimensions, this becomes pretty vital.
Sure.
Because as far as I'm concerned, having loads of data is useless unless you have that data in a format that we can process it as human beings. And it's very easy to reach a scenario in which we've got something that looks very impressive, but actually it's not really accessible for us. It's not helping us to make those decisions.
Is the HTML output interactive too?
Yes.
Cool.
So here is a graph that I've just loaded up, which I think you should still be able to see. So this is showing something slightly different. Instead of showing each competitor's current value in each territory, this is showing us their predicted change in each territory. So essentially, we have gone through every value we got from period 1 and every value we got from period 2, and essentially subtracted each variation of one from the other so that we can get an idea of how much variance we get. Now that increases our uncertainty loads because we now have the difference between the minimum value in period 1 and the maximum value in period 2, as well as the opposite. So we do end up with some fairly big swings here, but it gives us a much clearer idea of how we think specific competitors are performing. So we can say, for example, in Andhra Pradesh, we're not actually certain what the change has been over this time. We can make some educated guesses about what might have happened here, but this isn't the kind of thing that we're going to be making active recommendations on. Whereas in Delhi, things start to become much clearer. And it's not surprising that the variance here is much lower because Google's going to be sampling this data at country level. But they're not going to drill down into the individual territories and make sure they've got an equal sample from each. So if we're looking at a territory that's going to be most of the search volume anyway, our accuracy is going to increase much more when we're looking in that kind of area, if that makes sense.
Got it. Okay. So so the column, it's not a column, but Andaman and Nicobar Islands, how there's like crazy.
Yes.
What does that mean?
Yeah.
There's not a lot of data?
There's masses of variation here. And this is actually a tiny territory with very low search volume.
Okay.
So what we find when we are trying to gather data about those territories is they're going to be way more uncertain because they're a much smaller percentage of the overall sample. It's similar to, like if we're looking at GA data and we know it's sampled at 50%, it's much more likely that's going to be representative of our homepage than it is of a blog post that got 5 sessions in the last year, because the chances are that that blog post falls into our sample in a reliable way is much lower.
Okay.
So
I want to do a topic
on
forecasting. I think it would be freaking fascinating to wrap Python into how to do SEO forecasting. That would be fascinating.
I definitely agree. And there are some fantastic libraries out there that work really nicely with that, actually. So the Facebook has actually open sourced their prediction model in a project called Profit. Yeah, and that's very accessible through Python. And initial versions of the ODN platform, now Search Pilot, was actually running on Python. It's switched to another language now, but yeah, all of the predictive stuff runs very nicely in this language.
Got it.
So the only other thing I wanted to touch on, because I'm aware that your time is just as precious as mine, is that so you were saying before that you were having to work with transferring data from one place to another, particularly in terms of uploading things like crawls. And one thing I came across recently, actually, as I was stuck in a hotel in Amsterdam, actually, or in the Netherlands rather, was it's actually quite easy to transfer data from Dropbox to Google Colab. And then from there, you can put it into Google Sheets or wherever, like you're already authenticated and everything. And we'll probably just need to blur out this URL here. But basically, all I'm doing here is instead of running Python in Google Colab, I'm running a shell command. And this is saying, OK, go to this URL here and save everything that you get out of it, and then call that thing trends. And because Google has a great internet connection, and because Dropbox has a great internet connection, far better than mine, as we can attest based on recent issues, they can communicate with each other far more quickly than I can communicate with them. So the fact that I've been saving all this trends data to Dropbox over time means that Google Colab can go straight there, grab all of that data for me, process it, and then we can unzip it here in Google Colab and do whatever we want to. So this is downloading a whole bunch of data that I saved from the trends files, including some of those HTML files and stuff that I generated through Plotly.
Wow.
And now I can access all of them through the browser here. And the other thing I like about this is, again, because I've saved these all in structured files, the file paths carry across to here too.
Fascinating. How many hours have you invested in learning Python? Thousands? Hundreds?
That's a great question. I'm willing to say it's closer to thousands, but I'm also willing to say that I'm not as goal focused as I would like to be in that kind of way. So there are times when I think that if I had said, no, I'm not going to bother learning that side of things, I only want to achieve this one goal, I probably could have cut down the number of hours that I'm spending. And likewise, actually, reading documentation is so boring, but actually shaves loads of time off of the trial and error back and forth side of things. So I definitely think there are quicker ways to do that. I know we were chatting earlier about the process of learning coding languages, and often the people that are doing this, it kind of goes hand in hand with a real passion for the topic, and so it ends up really blurring the lines between this is work time, this is a personal project, that kind of thing, which I find really interesting as a topic, and something that I think we should be talking about when we're talking about the ROI on these kind of endeavors. Because
the so what question?
Exactly. Because I think that coding and coding applications can have a fantastic impact on what we're doing for our clients. It can drive us incredible ROI. But I think that when people who are already doing this stuff are talking about something like ROI, what am I going to get for spending 100 hours on this thing? It's very difficult for us to estimate, because a lot of the time we're picking up things like this outside of the time we're dedicating to that specific task. And you find that when you're a few months in, you end up using something that you've learned that was completely unrelated to that specific task. And it's very difficult to estimate at what point those kind of peripheral learnings start paying for themselves, as it were.
I've noticed that with my own workflows, where I'll develop a way of ingesting and outputting data that's super smooth and efficient, and then I'll use that and recycle that technique over and over again. And if I didn't have that knowledge in the back of my head, there are entire pools of problems that I wouldn't know how to solve.
Yeah, exactly. I couldn't agree more. And I think that and as you say, I think you often use that great term, synthesizing, like bringing together very disparate ideas. I think that's actually where a lot of the value lies. It's not when people are showing these fantastic solutions that make real difference to clients, or really real difference to the time that's spent doing something, the magic there isn't the code. The magic there is that a person has looked at a problem, taken a step back and thought, how can we use the other things that we've learned to solve this?
So forget about code for a second. What other ways of analyzing problems, like what should all SEOs learn how to do? Like, did you take statistical analysis in university, or like, what was your background coming in before we even got to code or got to SEO or whatever?
Sure. Yeah, good question. My degree was English language and philosophy. It didn't have any kind of statistical lean to it whatsoever. And honestly, having a deep understanding of the numbers and feeling like the content I'm producing, the answers I'm drawing are going to be accurate is something that I need to put active thought into. Like, it's not something that I just forget about. And I think in a number of ways that's a good thing, but I certainly haven't come to this with a statistics background. I have colleagues who have come to it with a statistics background, and I think it's one of the things that makes them great at the job. But I don't think it's the only way to approach it. I think that didn't come naturally to me. I'm very creative, and I'm very able to come up with ideas and to ideate in ways that other people don't. Like, my mind just doesn't work like other people's. But it's like a blessing and a big curse, because there are times when I don't think linearly. I think very non-linearly to solve problems. So yeah,
where do you put yourself on that? Like, how do you think of how you think? I don't know how to say it differently.
No, I really like that as a question. Actually, I'm going to start asking people that. I would definitely put myself in a similar spot to you. Actually, I would say that I don't tend to think in a terribly linear fashion. Like, I think one of the things that I bring to the table, if I'm being honest, is just as you're saying about yourself, thinking in a slightly strange way. I think that's one of the reasons things like philosophy appeal to me, because it's combining concepts that people either hadn't thought to combine or hadn't wanted to combine before.
Cool.
So yeah, I think that's a big part of the picture. I think that as a broad skill for SEOs to bring to the table, ignoring SEO consulting as a specific subset of that, I think the ability to be open to someone else just being better than us at a specific thing is really key. I think that, like, as a general approach, it's really hard to do. And I've got colleagues, I could name them, that are particularly good at just being open to someone else is really good at this thing, and I'm going to work with them on that. Or I'm going to just listen to them as they tell me how to do that. I think, we are working with, realistically, when we're trying to work in Google, we are either working with the world's biggest Rubik's Cube, or with fundamental marketing problems that have been scaled up to being completely global. And in either regard, it's not going to be possible for anyone to be an expert at everything.
Right.
So I think the more that we can work together on that kind of stuff, the better. I really struggle with that kind of thing personally, because I want to learn everything. And the idea that there's bodies of knowledge that I don't have is just a frequent source of anguish for me. But I think as I spend more time looking at the problem, it just seems clearer and clearer that, you know, we need to be able to work together on these things. And things like openly sharing code, for example, I think is a great step in that direction.
So 6 years ago, 6 years ago today was my last day managing a bike shop. And I had spent almost 20 years in a career working in the bike industry, working in and managing bike shops. And I knew that this was what I wanted to do, right? And I've always approached growth from a place of knowing how little I know and not being self-deprecating, but just being open to the fact that there's so much more to know. And also trying to surround myself with people who are smarter than me and who are open to collaboration. And I think that from a career path, to think that 6 years ago, I knew how to open up Google Analytics and have a general sense of what was going on, to being able to have conversations with people like you, it's just, I feel so blessed.
I mean, likewise. And for what it's worth, like, I think one of the hallmarks of this podcast series is a continuous respect for other people's expertise and passion and time. And it's one of the reasons that I enjoy listening to it so much, because these are all qualities that I want to have myself. Like, I think the more we can be passionate about the answers that other people have brought to the table, the more we can achieve and the more pleasant all of this stuff is going to be. Like, I can't think of a single SEO that hasn't at some point mentioned the fact that SEO Twitter at times can be a difficult place to be, because we've got different camps of people who feel that we should invest heavily in one thing or ignore something that someone else has been producing, and feel very passionate about these things, because a lot of the time they themselves are pouring hours and hours into research projects. So it's understandable that we all feel passionately about it. It's just, I think sometimes we forget that we're in an industry of very smart people doing very cool things, and we've got a lot of things to learn, and that's great.
Cool. Robin, this has been amazing.
Likewise.
So we're gonna have to have you back on. I'm wondering when it'll work out, right?
Yeah, no, we can definitely sort something like that out. Maybe, you know, with a more stable internet connection, and we can go through some of the more detailed things that we're working on at the moment.
I think this has been amazing, and I am glad that I was persistent on behalf
Likewise,
of
I've really
myself
enjoyed
and Jordan. And for everybody who's listening, it's super exciting. Jordan Chu's getting married on August 8th. Hands up high for our brother and his lovely fiancée, Nisa.
That's wonderful.
I know.
My sister's birthday, actually.
I'm so blessed to have you on, and I just wanted to say thanks one last time. Everybody, thanks for listening, watching, and we'll catch you on our next episode. Thanks, Robin. Pretty amazing.
Cheers.
Cheers. Ciao.
All right, it's been great.